Okay, so we didn't get a chance to finish this unit during our 2 days of in-class learning this week, so we're going to do the last two lessons, which would have been maybe a morning or an afternoon. We're going to cover that through these at-home videos. So these are lessons that are related to what we've done before. These will be part of the test when we get back, and you will use these two lessons to complete your assignment. So because we're not in class, we won't do a quiz, we're going to do a pen and paper assignment. And there's instructions in the Google Classroom of how you're going to hand that in. The lesson today is we're going to what are called transformations of parabolas. So we're always going to start with the basic graph y equals x squared. And what we're going to do is transform it into a variety of different parabolas. So we're always starting with this basic or parent graph, which we're going to call y equals x squared. And the first thing we're going to do is look at what does the a value do. So we've talked about the a value in class. It tells us the direction of opening. The a value can also stretch or compress the parabola. So the a value can stretch the graph of x squared by a factor of a. I'll talk about what that means to stretch the graph vertically. Or it can compress the graph vertically by a factor of a. And we'll talk about what compression means. So whenever a is a big number, so bigger than 1, and it could be negative or positive, but whenever a is larger than 1, and I use these absolute value lines, you may not have seen these before, all that means is 3 is bigger than 1. We're going to say negative 3. The absolute value turns into positive. So negative 3 turns to 3 is still bigger than 1. As long as a is a large number, so 3, 20, 23, anything bigger than 1. So for example, the equation could look like y equals 3x squared, or y equals negative 5x squared. So we're only looking at the quantity of the a value, not the sign. As long as that number is bigger than 1, the parabola is going to be vertically stretched. That's kind of our mathematical language. But what it's really going to look like is going to look skinnier than normal. So that's kind of everyday or colloquial way to explain it. And I'm going to show you what I mean on Desmos. So we're always going to start with our parent graph, which is y equals x squared. That's the red graph. And now we're going to look at what happens when I change that a value. So in our parent graph, y equals x squared, the a value is 1. We don't see it, but it's 1. Now we're going to look what happens when I make a larger than 1. It's as if I'm vertically stretching the graph. So imagine it's pinned at the vertex, and then I'm stretching it vertically. It's going to look skinnier. So imagine you're stretching something. It's going to look skinnier. The larger a is, the skinnier my graph is. So for example, if a is 3, we say that's vertically stretched by a factor of 3. So the graph is 3 times skinnier. We call that a vertical stretch. Same thing, if a is negative, but larger than 1, it still is going to look skinnier. So if a is negative 10, I've stretched it by a factor of 10. So we're not looking at the negative and positive right now, we're just looking at the absolute value or the quantity. If a is bigger than 1, it's going to stretch the graph. What about when a is smaller than 1? So for example, if a is 1/2 or 1/4, 0.3, any number smaller than a whole, negative or positive. So for example, we could say 1/2 x squared, or we could say, again, the negative doesn't matter, negative 0.2 x squared. We call that vertically compressed. And again, compression, imagine you're compressing a mattress, you're pushing down on it. I know that's kind of hard to see on my video. It's going to look fatter than normal. And again, I'll show you what I mean on Desmos. So now if I bring my slider to 0.5, or which we could also call a half, Desmos uses decimals. The blue graph, we're always comparing it to that red parent or base parabola, that basic simplest parabola of y equals x squared. But if I have a equals 0.5, it's going to be fatter or more compressed than normal. And same thing if a is negative 0.5, it's fatter or more compressed. And the smaller a gets, if I look at 0.1 or 0.01, now it's really fat. I've really pushed down. Imagine it's pinned at the vertex and I'm pushing down. We call this a vertical compression. And the way we think about that is if it's 0.5 or a half, that means I'm compressing it by 2. So imagine you're sitting on a mattress. If it's half the previous height, then I've compressed it by 2. So we'll kind of talk about more actually how to calculate that in a second. The last thing, and this is we already know, is if a is less than 0. We've talked about this actually a bunch in class already. So if a is -1, if a is -10, that means the parabola opens down. But if we're thinking about comparing it to the base or parent parabola, what we call that is a reflection in the x-axis. And I'll show you what I mean on Desmos. If I take this base parabola, y equals x squared, and I reflect it, or I make that a value negative, you can now think of that mirror line as the x-axis, and it's being reflected. If we were looking at y equals 5x squared, then y equals -5x squared, again, is that reflection in the x-axis. So it's just another way to think about the a value. It can either vertically stretch or vertically compress the parabola, make it skinnier or fatter. And it can also reflect it in the x-axis. It's another way of saying it goes from opening up to opening down. Next, so again, we're sort of looking at changing this base parabola to any other parabola. But we're going to use vertex form today when we talk about transformations. And what the h value does is we know that's the x-coordinate of the vertex. But another way to think about that is the h value is horizontally translating. And translate is just a way to say move in math. So translate is kind of a $10 word for move. If I'm translating the graph, and it's translating horizontally, so it's moving h units to the left or the right. So remember, h is always flipping signs when it goes in the brackets. So if h is larger than 0, so for example, y equals x minus 4 squared, well, we already know the vertex is 4, 0. You can imagine that whole basic parabola moving 4 units to the right. So the parabola would be shifted 4 units right. And I'll show you what I mean. Again, you may want to play around with some of these on Desmos yourself. We're always comparing to that base parabola, y equals x squared. Now I want to look, well, what happens when I change h? So if h is positive, and in our example we had h is 4, that parabola is moved 4 to the right. So for any positive h, so h minus 5, h minus 10, h is moving to the right. Which kind of makes sense, remember, because h was the x-coordinate of the vertex, and it's flipped when it goes into the brackets. Now, if h is less than 0, you can probably already guess what's going to happen. So if h is less than 0, it'll look something like h plus 2. Now, if h is less than 0, it would be like minus 2, so it's a plus 2 in the brackets. And that's going to horizontally translate, which just means we're moving, in this case, 2 units left. And we're not changing the shape, so we're not compressing or stretching. I'll show you in Desmos. So if h is less than 0, so for example, if h is -2, that means in the brackets it would look like h plus 2 squared, and I've moved 2 units left. So I've just taken the whole parabola and I've moved it to the left. I can write it out without the slider if it helps. So for example, h plus 2 is moved to the left, and we knew that from vertex form, the vertex would be -2, 0. So I've taken every point on the original parabola and I've shifted it 2 to the left. And when h is positive, it's shifting to the right. So the a value is compressing, stretching, reflecting. The h value is just moving left or right, and as you can probably guess, there's still one more parameter, which is that k value, which is going to vertically translate. Because remember that k value, the number outside the brackets, is moving our vertex up or down. It's actually moving every point of the parabola up or down by k units up or k units down. So if k is positive, that means the y value of our vertex is positive, so it's taking the original equation and it's moving it up. So take example x squared plus 5. The parabola would be shifted up or moved up 5 units. I don't know why I left in this second box. But we can call that a horizontal, or vertical. We can say vertical translation up 5. And we're going to practice this language on the next page. So vertical translation up 5. And if k is less than 0, so then the y-coordinate of my vertex is negative. So for example, x squared minus 3. That means I'm shifting down 5 units. So every point in the parabola is moving 5 units down from that base or parent parabola, that basic one, y equals x squared. So we can call that a vertical translation down 5. So we use translation in math to mean that we're moving something, but we're not changing the shape. So translation just means I'm moving something around, a shift, but we're going to use the word translation. So let's just look at that. So this is our last example. Again, we're always comparing to that basic parabola y equals x squared. Now we're looking at x squared plus k. So k is just moving my parabola up. It's not changing the shape. It looks like the shape is changing, but only because a different amount of the parabola is on the page. So if k is negative, it's moving down. If k is positive, it's going up. So for example, x squared plus k, it's the exact same parabola, but I've taken every point and I've moved it up 3. So those are our transformations. So it's just another way to think of vertex form. A, H, and K are all shifting, transforming, moving that original parabola, which is always y equals x squared. So we're going to put this all together. We're going to take parabolas in vertex form, and we're going to describe the transformations that have been applied to them. We're always going to apply translations in order of left to right. So the first one we're always going to do are reflections. So that means we're just looking if A is negative or positive. If A is positive, there's no reflection, but if A is negative, we reflected from our basic parabola. Then we're going to still look at A, and we're going to say, has it been vertically stretched or compressed? And we're always going to use this order. So that's still the A value. Then we're going to look at the H value. The H value is telling us horizontal translations, whether it's right or left. And then finally, we're going to look at that last one. That's our K value, and that's saying, well, have we moved this parabola up or down? So we're going to describe the transformations that have happened to each of these parabolas, comparing it to that basic parabola y equals x squared. So what do we need to do to transform this basic parent parabola into this parabola we see in vertex form? Well, first, there's no reflection because there's no negative sign, but it has been stretched. The A value is bigger than 1. So we say it's been a vertical stretch by a factor of 4. If you just want to write VS, that's fine with me. What else has happened? Well, there's an H value. H is 3. That means the whole parabola has been shifted horizontally 3 to the right. So the way we write that is horizontal translation 3 units right. And again, if you'd rather write HT instead of horizontal translation, no problem. And then we don't have a K value, so this parabola hasn't been moved up or down. Let's now look at Desmos to kind of check our answer. So in this question, we had the parabola of 4, x minus 3 squared. We want to compare it to the original. And sure enough, it's been stretched by 4, so it's 4 times skinnier. And then every point has been moved. You can see moved 4 to the right. Or 3 to the right, sorry. Have I been saying 4? I meant 3, because that's our H value. I think I did do it correct in the note. So we've moved it 3 to the right. So you can always check your answers in Desmos, but now we're describing these transformations. Let's do another one. Okay, so first, we always want to check if there's a reflection. This one does, because my A value is negative, so I would say reflection in the x-axis. Now, the A value is just 1, or the quantity is 1, so there's no stretch, there's no compression. There is an H value. Remember, H is always the opposite, because it's in the bracket. So that means I'm moving it 1 to the left, because the vertex is x-coordinate would be negative 1. So I have a horizontal translation 1 unit left. And now I do have a K value that's telling me what's my vertical translation. So I can say a vertical translation up 4 units. And I want us to use this language of translations in horizontal and vertical up 4 units. So I've had 3 transformations. I've changed the original basic parabola y equals x squared in 3 ways. Again, I'm going to look at Desmos when I do each of these. So this one was, so first what I did, I can't do this in order. First I reflected it. Then I moved it, we said 1 to the left, it was plus 1. It's not looking good, there we go. So it's been reflected, then it moved 1 to the left, and our final step was we shifted it up 4. So that's our new graph. every point has been moved one to the left and up 4 and reflected in that mirror line or that x-axis. Okay, again, if we were doing this in class, what I would ask you to do now is go through the next one on your own. So you're welcome to kind of pause the video and practice. But the idea here, again, we're looking at the a value first. Yes is a reflection because the a value is negative. So reflection in the x-axis. This time, our a value is less than 1. It's only a half. So what that means is that we vertically compressed it. But we don't say vertically compressed by a half. That doesn't really make sense. We always do 1 over, or we take the reciprocal. So we say vertically compressed by a factor of 2. So again, think of you squishing or sitting on a sofa cushion. If you compress it by 2, that means it's half of what it used to be. So you wouldn't say you compressed a sofa cushion by half. You'd say you compressed it by a factor of 2. So for compression, we need to flip. Next, do we move it left or right? No, h is missing. H is really 0. Again, we would never write this. But if you want to kind of, I'll do a little thought bubble. What you're really thinking is that it's x minus 0 squared plus 7. So we've already looked at this in class. There is no h value, so I'm not moving it left or right, but I am moving it up 7. So let's do a vertical translation, or VT, up 7 units. So I've described the 3 things that we've done to that original graph. Let's look at it again. So the first thing we did that time was compress it. Then the second thing is, the first thing we did was reflect it. Then I compressed it by a factor of 2, so it's now twice as fat. I've pushed down on it. And then I've moved it up 7 units. So those are my 3 transformations. So once we've described our transformations, when we look at the graph, you say, okay, yeah, that makes sense. This is what I've done to it. And we just have one more example. I'll go through quickly. Again, maybe pause the video and try this on yourself. We always want to list them in order. This one has all 4 possible transformations. It's got a reflection in the x-axis. It has a VC by a factor of 2. That means vertical compression. It has a horizontal translation. Remember, the h value is moving it left or right, but it's always flipped inside the bracket. So it's a horizontal translation, 5 units left. And it has a vertical translation, which is moving our k value is -1. So a vertical translation, 1 unit down. So the most we can ever have would be 4 transformations to a quadratic. It can reflect or not. It can stretch or compress. It can move left or right, and it can move up or down. So that's our lesson for transformations. We've got some homework problems in the book. Oh, no, we don't. We have questions on a page here. So this is kind of your independent practice. It's quite similar to what we've been doing. So you're going to list the transformations. In question 2, I've listed the transformations, and I want you to write the new quadratic equation in vertex form. The answers are on the bottom. Again, send me an email if you have any questions. Once you've practiced this skill, then you'll be ready to move on to our second video lesson of today, where we're going to use some of this knowledge to graph quadratic equations instead of just sketch them like we've been doing. Okay, best of luck with transformations.